Hello grade 11s and welcome to my channel, and hopefully I can be of some assistance. So let us review this paper from grade 11 written this June from Limpopo province, looking at paper 1 for maths. Okay, and I can tell you this entire paper is material that is examinable in matric. So if you're doing grade 12 and you bumped into this video, don't run away just because it's for grade 11s. It will take you through your matric. If you're doing grade 11, please pay attention to the techniques that I'm going to show you here, because they will carry you through your grade 12. Otherwise, let's have a look at this paper. It's a 2-hour paper. So what is important here is instructions. So obviously we know that if we're doing any determinations, we can do calculations, we can use diagrams, graphs, etc. That means anything that is acceptable in maths. Okay, you need to show whatever you have used. And then of course we know that technically the issue of rounding off, here we are told to correct to 2 decimal places. That means no more, no less than 2 decimal places. And then of course be aware that diagrams are not drawn to scale. So essentially don't try to read directly from the diagrams, but at least see the implications of those diagrams. The other issue is the numbering. Number them according to the system of this question paper. Anyway, now that we are done, let's get to question 1. So question 1, we are dealing with quadratic expressions mainly, but at times they can mix them up in grade 11 with other algebraic expressions or equations. All right, so let's start. So question 6, 1.1. Why did I write question 6 now? Here one. So this is 1.1. See, the brain sometimes can do stupid things. So please watch yourself. So we're given 2x into x minus 3 is equal to 0. So this quadratic is already factorized. So once it's in factors, we know that 2x is equal to 0, or x minus 3 is equal to 0. All right. And therefore, we know that x is going to be 0, or x is going to be equal to 3. Okay. So that is what you do. And then, of course, it's easy to make a mistake of just a sign. A simple as sign can mess it up. So you put it back. If you substitute 0 there, the whole thing becomes 0. So the left-hand side equals the right-hand side. If we put a 3 there, we get a 0. The whole thing becomes a 0. So we know for sure that those answers are correct. And we're getting marks for the answers because that was already factorized for us. So 1.1.2, we're given here 3x squared minus 2x is equal to 4. And we're told here correct to 2 decimal places. This already says a quadratic formula is applicable or completing the square. By the way, those two are one and the same thing. But now we need our quadratic in standard form before we can solve further. So we've got 3x squared minus 2x. We transpose the 4 is equal to 0. Now we are happy because our quadratic is in standard form. That becomes our a value. This becomes our b value, which is the coefficient of x. And then the constant term becomes our c value. Okay, great. So we can simply say this implies that our x is equal to minus b plus or minus the square root of b squared minus 4ac, which is what we call the discriminant, or delta. So this is 2 into a. Okay, so now we substitute into this equation, nice and easy. So this is minus Our b value is a minus 2, plus or minus the square root of, here we've got minus 2 squared minus 4 into minus 4 into 3 into minus 4. Okay, so again here, make sure you do a careful substitution, because that is what can be a problem. An incorrect substitution will lead to an incorrect answer. So make sure you watch yourself and you double check. Just because it's easy, don't take it too lightly. So minus into minus 2 plus the square root of minus 2 squared minus 4 into 3 into minus 4. Okay, divide by 2 into 3. How? Because, yeah, 2 into 3. If so this is 1 comma 542 decimal places, or our x is going to be equal to, let's just go back here, at least this one saves us from an unnecessary long process. So these calculators are the best, guys. So get yourself a Casio and you will not regret buying it. So this is now 872 decimal places. Okay, so those are the answers for our story there. Now, the best thing to do to just make sure you did not make a meal, take these values and substitute into the original. Now, round it off to the nearest integer. You should get a 4. If you don't, you know that you are dead, okay? You substitute both, and this area of substitution is a mark. So they were giving us 4 marks, so probably for writing this in standard form is the extra mark, okay? So 1.1.3. So we're given here a quadratic in said form. So we've got here 5 minus x is equal to x plus 1, okay? So what do we do here? We know that this is a positive square root, so we just repeat. We just repeat the thing. But this time we're going to perform some inverse operations. To remove a square root sign, we square both sides, right? Right. So when we take the square of whatever we've got there, it becomes 5 minus x, right? Because even if this was negative, it comes out positive now. And then this side we FOIL. It's going to be x squared plus 2x plus 1, okay? This implies now when we rearrange, we get x squared plus 3x essentially minus 4 is equal to 0. Okay, then we can do factorizations from grade 10. So this is x. Now the sign of the positive one is going to be 4 and 1. So 4 must be positive, 1 must be negative. Therefore, our x is equal to minus 4, or our x is equal to 1. Now, which one of these two is correct? So let's put minus 4 in there. So we're going to have 5 minus minus 4, it's plus 4, which is 9. Square root of 9 is a 3. When we put a minus 4 plus 1, it's a minus 3. So basically, this doesn't give us the left-hand side equaling the right-hand side. Even though we know we were supposed to get a plus or minus, the problem is that this is already a positive square root, so we just forget about the plus or minus story. If we put a 1 in there, it becomes a 4. Square root of 4 is a 2. 1 plus 1 is a 2. So this one is correct. So of course we get a mark for rejecting that. Then we get a mark for our inverse operations. And we are getting 5 marks. Okay. So that means getting to this quadratic is another mark, and factorizing it is another mark. Okay. So that's how we get those 5 marks. Nice and easy. So let's do 1.1.4. So this one, we're getting a quadratic inequality. So this is 2x squared plus 5x less than or equal to 3. Okay. Again, when you're dealing with inequalities, always put expressions, whatever expression you've got, in standard form first, or at least isolate the 0. If you don't do it, it's going to kill you. All right. Now that we've got our quadratic in standard form, we can actually attempt to factorize. You will hardly be given something that is not factorizable. But if it is not, you still have the quadratic. Okay? You've got the quadratic formula to solve something that is not factorizable. So don't always think you're going to get it in a factorizable form. And then here we can put our 3 and our 2. No, our 1, sorry. Because 2 times 3 is a 6. 6 minus 1 is a 5. So this means this must be positive and that must be negative. Okay. Great. So what do we do now? We take our binomial factors. We put them onto our algebraic table or arithmetic table or just a table. Doesn't matter how you look at it. Okay, I'm going to show you the table method and the graphical method because I feel like these two are very important even when you're doing functions. If you don't know these two, you will struggle with functions, so it's always important. So we're doing a product. Okay, what would be the x value here if we equate that to 0? It would be a half. Okay, if we equate this to 0, the x value would be a minus 3. So we always put them in ascending order. Now we start. We say, when will this... Oh my God, why is it going to link to number dot? So we ask ourselves, when is this 2x minus 1 going to give us a 0? When x is a half, right? Because then we'll get 1 minus 1, which is a 0. If we put a value greater than a half in that expression, what do we get? We get a positive answer. Okay, that's cool. Take, for example, a 1. 2 minus 1 is a positive 1. And it continues like that. If we establish a 0 and a positive answer, we know that here they should all be negative. But just double check in case you're making a mistake. Any value between minus 3 and this half, take a 0 out of convenience. Then we get a minus 1. When we put a minus 3, we get a minus 7. And we take a number less than that, we put a minus 4, for example, we'll get a minus 9. So that is correct. Then we ask again, when will be the next binomial factor x plus 3 give us a 0? When x is a minus 3. So it's always nice when you establish where the zeros are. Then let's say we put a number greater than minus 3 but less than a half. If we put a 0, for example, we get a positive answer. And it should continue like that. It never really changes. So this is a number line. But do double check in case this is not the case, all right? And then now we come here and say we are actually doing the product. So minus times minus is a plus. Minus times 0 is 0. Minus times plus is a minus. 0 times any number is 0. Plus times a plus is a plus. So now when, remember this is our solutions. We'll read our solutions in this line, okay? So when is this happening? We want 0. So we're getting zeros at minus 3. We're getting zeros at a half, right? So these are included, therefore. So we shade. And then, when is it less than 0? In between them. So we connect them with a bar. That is our solutions. So we would say now, therefore, x must be less than or equal to a half. Or x must be less than or equal to, sorry, must be greater than or equal to 3. So that's the solution. All right. So basically, what do we get here? How many marks were we scoring? 4 marks. So first of all, we know that this helps us to get the critical values, which is these dudes right here. All right? And then this table helps us to determine our answers. Remember they said show any graph or diagram that you used in determining your answer. So that's why this has to come up. And normally this one, you get 4 marks for it. 2 marks for it. So that could easily be how you score those 5 marks. Alternatively, you can use the graphical method. It is very important as well. Like I said, in functions, you're going to be coming across this more often than not. So if we inspect and say, okay, our parabola, this expression is what gives us the quadratic. Our a value there is greater than 0, right? So if a is greater than 0, we know that our parabola is a smiling parabola. Great. So we can easily start drawing our Cartesian plane. And then we do it. Then we will see that, okay, we have a situation where this is positive and that is positive. That means our turning point will lie to the left of the origin. Okay, these are some of the things you need to know. Okay, you need to know these. So basically our parabola is going to do stuff like this. All right. Now, what do we know? We know that the critical values from that factorizations will give us a -3, will give us a 1. A half, sorry. That is what we got, okay? And then our turning point is at our y-intercept is at -3. That is the constant term there. And we know that the turning point the x-coordinate lies to the left of the origin. So that is the most important thing. And then now we ask ourselves, when is our graph equal to 0? Easy. It is equal to 0 at this critical value, and it's included, therefore. And it's also equal to 0 at this critical value, and it's included also. And in between, when we connect these two, that graph becomes negative, because in this region, this graph is negative. You can see it's below the the x-axis, and then we can make the same conclusion as we have made there. Okay, so these two are very important. Please know how to do them individually and effortlessly, because you're gonna get far if you know those ones. Okay, let's go on. We've got 1.1.4, 0.5. Okay, we are given here 5 to exponent x. Sorry, 5 to exponent 2 over 5. Maybe let's put it a bit bigger because it's starting to challenge me. So we've got 5 x to exponent 2 over 5, right, is equal to 20. Now, what do you do here? Well, there's a lot of things you can do, but sometimes it's going to be a horrible situation. The best thing is to convert this into surds. So what we've got here, we essentially have a square root. Of course, you can do trial and error. It won't hurt. So this is 5x squared. The one on the numerator remains on the numerator, right? Right, and then this is going to be the 5th root of what we've got, equals 20. Now here we can just simply employ inverse operations, and then we just simply, if we have a 5th root, we're going to take that to the exponent 5, right, to undo that. And then what we do on the left hand side, we must do on the right hand side. So this essentially leaves us with 5x squared equals 20 to the exponent 5. Remember, here we can use a calculator, so we are not limited to that. So we can just put it, whoa, let's just leave it as 20 to the exponent 5. That is ridiculous. Okay, and then we divide by 5 throughout. So we get x squared is equal to, and then we sort this out. Say that which we saw divided by 5 is also still a crazy situation. Yeah, when. So this one, why do I feel like I'm doing crazy materials? This thing is horrible. It's horrifying me now. Oh yeah, that was a mistake. That 5 should not be inside. So anyway, let me try to do the right thing. See, sometimes trying shorthand methods, you run into problems, and I'm going to lose time, which I am not intending to. Now let's sort this out. This is the same as this. We divide by 5, by the way. Let's just do the simple thing, simple procedure. We'll have x to the exponent 2 over 5 equals 20 divided by 5 is a 4. All right? Right. This now implies that we essentially have x. Now we can do that which we wanted to do. This means the 5th root of x squared, okay, is equal to 4. Nah, not a problem. And then we perform our inverse operations there. What we do to the left hand side, we must do to the right hand side as well. Great. So let us see, what is the story here? This leaves us x squared equals 4 to the 5. Yo, this is still crazy, eh? It is still crazy. Now to the exponent 5. Oh, at least it's better. This is 1024. Okay, it's not as horrifying as that one. And then we're trying to solve for x here. So I don't know, guys. This is a difference of 2 squares, so this is fine. We can now finally do this, but anyway, to avoid putting the square roots when we actually removed them. So this is x squared minus 1024, okay, which is equal to 0. So what you do on your calculator, you will just take that 10, what is this? This is 1024. And then you press answer, and then you press shift, and then you press a button called fact. This gives us a 2 to exponent 10, which we can actually reduce to something like 2 to the exponent 5 squared, right? So that's basically 32 squared. Yeah, that's 32 squared. So basically, all you do, you just take that 1024, you press an equal sign, it will still write that 1024, okay? And then you press shift, and then you press the button written fact. It will give you something like 2 to exponent 10. You just play your tricks there. You know that you want a square, so this is going to be 2 to the exponent 5 squared, right? And then 2 to exponent 5 is 32 squared. So you got it. So these are some of the procedures you want to actually play, okay? This is shift button. This is the fact button. How do you recognize that? It has something like this. So that button has something like that. That's how you could recognize it. And then you just play your exponential tricks depending on what you're looking for. And then we know that, okay, this means we can say x minus 32 here into x plus 32 is equal to 0, because that's the difference of 2 squares. Therefore, our x is a 32, or x is minus 32. Now, what do we do here? We have a bit of a situation, don't we? Yes, because now we have to decide, do these work together? The answer is, let's find out. So let's say 5 into 32 and then all to the exponent, what? 2 over 5. Let's see if we get a 20 there. The answer is a 20, so this one works. So now when you put a minus 32, we definitely are not going to get it. Right. So this one, it gives us a 20. By the way, I forgot there's a square in there. So that is correct. Okay, so that is the story there. So we've got our 2 marks. Wow, this guy. What on the Lord's earth is this thing? So basically, we're just getting those marks only. Perhaps there's a shorter method that gives you those answers quickly. It doesn't matter. Both of them are correct, and they decided. Basivimba is sweet. Basinikeza nje umdlalo akunankinga. 1.1.6. Now we've got here 2 to exponent x minus 12 over 2 to exponent x equals minus 4. Okay, now once you have fractions, make sure everything is in a fraction. Then we know that what are we looking for? We want the LCM. So we will just multiply throughout by the LCM, which is going to be this 2 to exponent x times 1 times 1. This becomes just 2 to exponent x. Okay. So we'll multiply by the LCM. Please take note, this is correct. The word LCD is a misnomer. Okay? This word is a misnomer. Never use it because it's not correct. Remember, when we're saying the lowest common denominator of these denominators, which one is the lowest of the 3 that is common? Is 1. But can 1 accommodate 2? No. But 2 does accommodate 1. So probably you can say the highest common denominator. Because of the denominators, this must accommodate itself and the others. So therefore it becomes the highest of those denominators. But now we choose that. We can actually call it the common denominator. In fact, I think it's fair to do that. But because 1 and 2 to exponent x are two different things, we actually can't say this can accommodate these ones. Hence, we're taking a multiple. So we're multiplying them. Okay, not a problem. So that is what we're doing. Now, if we multiply, it will be such that, what do we do? This multiplied by that is going to be 2 to exponent x times 2 to exponent x minus, here it's going to be 12 equals minus 4 times 2 to exponent x. That's what we've got. All right. This will imply that we've got 2 to exponent x times 2 to exponent x. Transpose that, it becomes a plus 4 times 2 to exponent x minus 12 equal to 0. So this is basically a quadratic in exponential form. So we can actually factorize this grade 10 style. So this is 2 to exponent x to exponent x. Now factors of 12 that can give us a 4 is a 6 and a 2. But now we want that to be positive. So 6 must be positive. This one must be negative. And we are sorted. We are sorted. So we can say, therefore, 2 to exponent x is 2 to the exponent 1. Or 2 to exponent x is equal to minus 6, which is not possible. A power with the variable on the exponent can never be negative. it doesn't matter. Even if the exponent is negative, it only becomes a fraction, but it can't be negative. So that is easy. And then therefore it tells us that our x is going to be 1, because remember, when powers, remember this whole thing is a power. But now what seems to be the stronger determinant of what is that value? It is the base. So it's the power of base 2 raised to exponent x, or index x. Okay. Now once the bases are the same, we take the exponents, and that is the value of x. Okay, so that is it. Now let's see, how many marks are we getting here? 5. Okay. I believe this step is important. And I believe this step is also important. I believe rejecting this answer is important. And accepting that is important. And the final answer is important. So that's how probably those 5 marks are arrived at. Okay, great. So let's do 1.2 quickly. We are losing our 30 minutes. We're supposed to do this in 30 minutes time. So simultaneous equations is very important. Why? Because in functions, you're going to be solving simultaneously when you're given 2 graphs that have points of intersection. Okay. So let's quickly start with this one. 5y minus x is equal to 2, which implies that x, if we transpose x to the other side and rearrange, x is going to be basically 5y minus 2. We can make that equation 1, and then we're given x squared minus 3xy plus 4y is equal to 4. We can make this one equation 2. Obviously, this is some sort of a circle, and that is a linear. What you call linear equation. So now let's have a look. We will just say put 1 in 2. So this is such that where you see x, we put 5y minus 2, and then we square. Minus 3, where we see x, we put 5y minus 2, and then we put a y there, plus 4y is equal to 4. So we just simply substitute. And then we FOIL things. So this is 25y squared. This is going to be minus 10. Minus 10, so it's going to be minus 20y. And then plus 4, okay? This is 5y squared minus 2y. So this is going to give us minus 15y squared plus 6y. Okay, I'm moving a bit quicker, guys. So plus 4y and equals 4. Now, obviously, 4 is positive on this side and on that side. So what is going to happen? These ones will cancel when we move one to the other side. It's already done. And then we start with this guy here. We know that this guy minus that one is going to give us 15. No, 10. 25 minus 15 is 10. 10y squared. And then we're going to handle this one. We're going to say minus 20y plus 10y is going to give us a minus 10y is equal to 0 because the 4's fell off. And then here we know that we can take out the highest common factor, which is 10y. We remain with y minus 1 is equal to 0. Therefore, we know that y is 0 or y is going to be 1. Okay, great. Therefore, x is going to be 5 into 0 minus 2, or x is going to be equal to 5 into 1 minus 2. This is going to be simply minus 2. This is simply going to be a 3. Okay, now once you get to this point, you want to double check if your solutions are correct. You take this pair minus 2 and 0. You substitute into one of the original equations. For example, we've got 5y there. So now 5 into 0 is already 0. It falls away. And then minus into minus 2 is going to be a plus 2. So plus 2 is equal to 2. So this means these solutions satisfy our equation. Then take the other set. Coincidences do okay. Take the other set and test it as well. So when we put y as 1, this is going to be 5, right? And then when we put x as 3, therefore 5 minus 3 is a 2. So 2 is equal to 2. So also this pair checks out. But do make sure that your substitutions are correct in this step, because coincidences do okay. You find that everything checks out, but you made a mistake somewhere. Sometimes life can forgive you even when you make a big mistake. So how many marks? 6. So we've got 4 already. So substituting into the other, that's the 5th mark, and sorting out that one gives us another mark. Okay, please attempt to do question 1 in 30 minutes. Of course, this is what you need to work towards when you practice, because you don't want to lose too much time on question 1. It's pretty straightforward. But I took some time to explain a thing or two which you don't really do when you're writing the exams, so you're not going to run into any issues. So let's do question 2. Ideally, you should be doing this on a new on a new page, but I really do not have that luxury, or should I say I don't have that restriction. Now question 2.1 says simplify the following without using a calculator. So this means we need to see every step using laws and rules that are acceptable in arithmetic. So this is still algebra, sorry. This is algebra. So 2.1 is divided into 2.1.1. So we are given here 8 over 27, all raised to the exponent 2 over 3. Okay, so basically, if we want to solve here, we can't have a fraction. So the key is that we need to eliminate u. The best way is to see, can we express 8 as a power of a particular base raised to exponent 3? And that should be the same for 27. The answer is yes. So we know that 8 is 2 cubed over 3 cubed. So the question says, or the technique says, express these values with their prime bases. So that's how it is made. And then now we can see that, okay, if we've got the same exponent at the numerator and the denominator, this is the same as 2 over 3 cubed, all raised to exponent 2 over 3. So we're using exponential rules here. Now you can see here that this is going to be 2 over 3 cubed multiplied by, so now when you sort up that big bracket, it becomes 2 over 3. And the magical thing happens that we actually saw we needed to do. So now what remains is basically 2 squared, which is 4, over 3 squared, which is 9. So please don't prolong too much. Of course, these ones have a tendency to take up space and time, and yet the marks are not that many. We're getting only 3 marks. So obviously for changing those two into those cubes is important, and essentially factoring out that exponent is important. The rest of the gymnastics, honestly speaking, is what should happen. Okay, I think that is cool. We've got our 3 marks. So 2.1.3. We are given a 2.1.2. So we are given here the square root of 12, okay, plus 2 into the square root of 3 minus 1. So which says you always try to do these into prime bases, so to speak. This looks like a difference of 2 squares if you look at it, but let's see. This is equal to the square root of 12, basically is the square root of 4 times 3, because our key is this. Our key, we want to make 3 to appear somewhere in the other expressions. This is now the square root of 3 minus 1. Okay, so when we simplify further, this is 2 root 3 plus 2 into the square root of 3 minus 1. Okay, that's nice. And then now we do FOIL method. Remember now, root 3 times root 3 is 3 times 2 is basically 6. Right. And then we take this, we get minus root 2 plus, we get minus 2 root 3 plus 2 root 3. That goes away, it becomes a 0. Then 2 times minus 1 is minus 2. So the answer is a 4. So you see, that was a difference of 2 squares, but hidden in some way. Okay, so what is important is this guy, and then getting to this step by doing FOIL method and the final answer. I'm sorry guys. I don't know why I'm coughing now, because I'm not really sick, at all. Okay, let's go on. 2.1.3. We are given a very lengthy expression there. We've got 3 to exponent 2x plus 1 times 15 to exponent 2x minus 3 over 27 to exponent x minus 1 times 3 to exponent x times 5 to exponent 2x minus 4. So when you get these complex exponential expressions, make it a point that you don't make mistakes, okay? Now, whenever you've got big numbers like that, the rule is express those into their prime bases. Okay, you can't change a 5, you can't change a 3, those are prime numbers. But those ones are multiples of prime numbers, is it not? So we sort it out. We will still maintain here, we've got 3 to exponent 2x plus 1. But here we're going to have here 3 times 5 to exponent 2x minus 3. All of that, we can see 27 is basically 3 cubed into exponent x minus 1 times 3 to exponent x times 5 to exponent 2x minus 4. So now everything looks all right, but we just have to simplify. And here you need to be patient. Don't rush anything. So this is 3 to exponent 2x plus 1. These ones are totally annoying. Now you distribute the exponent to the 3x and to the 5. Not to the 3x, but to the 3 and to the 5. Okay, now that everything looks set, so this is going to be 3 to the exponent 3x minus 3 now. Okay, times 3 to exponent x times 5 to exponent 2x minus 4. So this one is annoying, please be aware of that. Now let's see, what is the story? Now we just want to put everything into the numerator, because now the numerators have relatives in the denominator. So now when you take powers with the same basis on the numerator, first of all, this one is on the numerator. So when you're multiplying powers with the same basis, what do? You simply add the exponents. So we'll start with that part. So what do? We're going to have 3 to exponent 2x plus 1. That is the first one. But now when multiplying this power, we will simply add that exponent plus 2x minus 3. So this one won't be affected if we are adding. But then we're going to subtract this one because it's on the denominator. So we simply subtract the exponents. So this is 3x minus 3. This is just going to be boring, I'm telling you. And then, again, we're going to subtract this x here. So that's what we do, okay? And then we deal with the 5. So this is 5 to exponent 2x minus 3. This one is on the denominator. We simply subtract that one as well. So now that everything is in order, we just sort it out. So what do we do now? We've got 2x plus 2x. It gives us a 4x. Now a 4x minus 3x. So this, that, and that. So this is 4x minus 3x. This is x minus this x. It basically gives us a 3 to the exponent 0, or the x's fall away. So we only get 1 minus 3. So 1 minus 3 is basically to the minus 2. Wait. 1 minus 3 is minus 2. Minus 2 plus 3 is a 1. So basically it's just a 3. Times, now let's see. This is fine. So this is also taken care of. All right, great. Then let's come to this one. 2x minus 2x, those fall away. Then 3 plus 4, it's a 1. So essentially we get a 5 here, because these ones also do it. So 3 times 5 is just 15. Okay. That's very interesting. And then of course, if you are a math student, you can assign a value for x and see if you're going to get the same. Let's go for it. We've got 3 to the exponent. This one is going to be 2 into, now x, we're giving it a 1. Let's just give x a 1, and then plus 1. And then we're going to say into, let's just put a multiplication there. 15 to the exponent 2 into 1. So we're making x1, okay? Minus 3. Divide by 27 to the exponent. Now we're going to have 1 minus 1. Okay, multiplied by 3 to the exponent 1. That's just a 3. Multiplied by 5 to the exponent 2 into 1 minus 4. Okay, your calculators are fancy, guys. They can do it. So I'm getting 15. So that means whatever manipulation we did is correct. So please double check. When you have an expression like that, just assign a value for x and work it out on the calculator. Even though you were told don't use the calculator, just work it out on the calculator. You then check if your answer is correct. That's it. Okay, so that was 4 marks. Now, I believe this changing and that changing a sign. This thing likes to happen though, and I hate it, you know. Anyway, so now we can see that, okay, those two changes are important, and 2 marks are already in the bag. And then I believe the other mark is for all this shenanigan right there. Okay, that's the 3rd mark, and that would be the 4th mark. Okay, so a lot of work for not so much. All right, not a problem. So let's do 2.2. Okay, so now for 2.2, we are told here, without using a calculator, show that root 2 over root 2 plus 1 plus 4 over root 2 simplifies to this value right there, which is 2 plus root 2. Okay, so we are given root 2 over root 2 plus 1, and then plus 4 over root 2. So these expressions need you to rationalize the denominator. That's just a clue here. How to rationalize a denominator that is a binomial like that? We simply use conjugates. We multiply by 1 that is made up of conjugates of that denominator. So this is the same as root 2 over root 2 plus 1 multiplied by 1, which is made up of conjugates of our denominator, because we know when you do that multiplication for the denominators, it will simplify to a rational number, because that creates a difference of 2 squares, and we know that the difference of 2 squares is a rational number. So here we've got 4 over root 2. Now this one is a single square root sign, so once you have a single radical, you multiply by 1 that is made up of those radicals, because in the denominator it will give us a rational number, because that gives us a perfect square. A perfect square is a rational number. All right, not a problem. Let's move on. So basically this is going to be root 2 times root 2 is basically just 2 minus a root 2. Okay, because root 2 times 1 is that. Then now what happens on the denominator? These ones is just going to be 2 minus 1. Okay, plus here we're going to have 4 root 2 over, now this becomes 2. Great stuff. So this is 2 minus 1, which is just 1. That thing divided by 1 is basically 2 minus root 2. Here 2 cancels, goes 4 times, so this is going to be plus 2 root 2. Now plus 2 root 2 minus root 2 will leave us 2 plus just 1 square root of 2. And that's it. That's it. Okay, so that's good. Very easy and straightforward. But this question can haunt you if you're not careful. You need to be smart about it. It can cause a few issues. Okay, so what do we do now? 4 marks. Okay, I guess multiplying by those ones, which are special ones, we get 2 marks, right? Right. And then working out this part, we get a mark, and working out this part, we get a mark. We don't really get a mark for the answer because it was already volunteered for us. So let's do 2.3. 2.3 says, determine the value of m if x squared minus xm. So we've got x squared minus xm, no, mx, okay, plus m plus 3 is equal to 0. Must have equal roots. Now once you talk of equal roots, we're talking about nature of the roots. And then of course this is already in standard form, because here we've got an invisible 1 as the coefficient of x. That gives us a. And then here we've got minus m as the coefficient of x. That gives us a b. And then we've got this complex c value there, that's a c. So we can actually use the discriminant here. This is a question on nature of the roots. So we can say for equal roots, it is such that delta must be equal to 0, right? So this means b squared minus 4ac is to be equal to 0. And we continue doing our substitutions. Our b is minus m squared minus 4 into 1 into c. Sorry. Our c is just m plus 3 equal to 0. This is m squared minus 4m minus 12 equal to 0. Okay. This implies we can factorize. This is going to be m. Factors of 12 that can give us a 4. It's a 6. Sorry, and a 2. But now the 2 must carry the positive. The 6 must carry the middle term sign. So we can see that m here must be minus 2, or m must be a 6. Yo, let me drink some more. Okay guys, so I've had my water and I'm good. So now what do we do? It is important to check if these are correct. So for example, we substitute a minus 2 there, so it becomes a plus 2. So our expression becomes x squared plus 2x plus, so minus 2 plus 1, plus 3 is a 1. So let's see, when we factorize this thing, what happens? So do you see? Therefore x is minus 1, so there's equal roots. So this is correct. Cool. And then let's work out the other one. I don't know why my throat is acting up now. So this is going to be minus 6x plus 9 equal to 0. Then when we factorize this thing, gonna x minus 3, x minus 3. Therefore x is a 3. Again, there's equal roots, so that is correct. Okay, sometimes double check, because you may have to reject an answer if it is not satisfactory. So that is it. We've got our two values of m, and essentially substituting into that equation is important. And then coming up with this quadratic is important. 4 marks, maybe not necessarily there, but I do believe that either this or the other one is important. But what is more important here now is this factorization here. Okay, that's it. So that's it for question 2, and we are scoring our 19 marks with a smile on our face, because we know our algebra. Here we were getting, did we make our, yeah, no, we did not. So here we got 29 marks with a big smile, a very wide smile. Now we added 19 to that smile, so yo mlomo zawuchazuka luncumo lungaka. Anyway, let's do again. You should be you should be in a new question here. Okay, so question 3 goes like this. So we are given here, let's just work on this one. We are given the function of f. Okay, so what do we understand by this function? We can see that we have a 1 on that numerator. This tells us that our a is greater than 3, right? So when a is greater than 3, you should know what that a is all about. Okay, please, I don't need to explain that. So this already tells us that we expect our graph on the Cartesian plane to look stuff like this and stuff like that. All right. Okay, so that is what we expect. Now we continue our exploration. Now when we look at the denominator, we know that that denominator gives us our vertical asymptote. It means our vertical asymptote will be such that x is equal to 3. You just simply equate that expression to 0, and we know that our vertical asymptote is going to be at 3, or the opposite value of that constant term in the denominator. That's cool. Now let's look at the last one. Maybe let's check another color. Now this one we know gives us our what we call vertical asymptote, and that horizontal asymptote, it is the y value. So y is as it appears. Okay. So we've dissected this. Okay, now that we have done our job, so analyzing this given function makes life a lot easier, because to answer these questions becomes a lot easy. Okay, so it says now write down the equations of the asymptotes. So it says write down. So all you need to do is to just say 3.1. We have, okay, maybe we can just write our function first. So this is 1 over x minus 3 minus 2. Now, to answer 3.1, we know that x is going to be equal to 3, the opposite of that which appears on the equation, but y is going to be equal to 2. And we know that those asymptotes are essentially the shifts, the vertical and the horizontal shifts of our standard hyperbolic function. Easy stuff. So 3.2 it says determine the x-intercept of f. Okay, so now we know that for x-intercept, it is such that 0 is equal to 1 over x minus 3 minus 2. So you just want to move, because you know that this is the implication. Now we transpose the 2 to this side and we leave it as a fraction. So this is going to be equal to 1 over x minus 3. We do cross multiplication here. What do we get? We get 2x minus 6 is equal to 1. Which also implies that 2x is going to be equal to 7. Therefore, x is equal to 7 over 2. So, this seems to suggest that our x-intercept is going to be 7 over 2 is to 0. Of course, they didn't say coordinates of the x-intercept. They just said the x-intercept. So the answer is here. But the other one is just simply to be complete, honestly. Anyway, so substituting that 0 there is important. And this entire substitution is important. The rest is history. Now let's get to 3.3. 3.3 says sketch the graph of f on the attached diagram sheet. So now here they are dictating what you can use. You're not going to do your own thing, okay? Clearly show all the intercepts with the x's and the asymptotes, okay? But now we don't have the y-intercept, so let's work out the y-intercept. It's important. So y-intercept implies that we have got y is equal to 1 over 0 minus 3 minus 2. So this is basically minus a third times minus 2. It's becoming a plus 6. All right, plus 6 plus 1 equals 7. and divide by minus 3. So this is going to be minus 7 over 3. All right, not a problem. Now that we have a y-intercept, we can simply say here, therefore, our y-intercept is such that we've got 0 is 2 minus 7 over 3. That's it. We did need this one. So now let's go and get this grade that they want us to use. There it is. Okay, so we've got fancy things that help us to do fancy work. So let's go for it. So we've got stuff that does magics here. So we just do the magics. We do the magic. Is nice, is it not? Now we just draw the thing. Don't know why I'm becoming a lot throatier now. It's getting irritating, I'm telling you. Of course, you would have written your name there and whatever, because this can go missing, and then when they find it, they don't know who it belongs to, so you write it. So everything has been labeled for us. It's nice. So we know that our vertical asymptote is this one. X equals 3. Okay, and then our horizontal asymptote is y equals minus 2. So basically they were saving you time here. But I like to show my asymptotes in a broken fashion to show that they are different from the graph line. Okay, so we label them, right? Oskov. So we're going to say this is y equals minus 2. This is x equals 3. So now what is next is for us to draw the graph. So let's make it a bit colorful. Now, what do? We know that our y-intercept is 3,4. Our x-intercept is 3,4. So this is halfway between 3 and 4. So it's 3,5, sorry. Okay, so we know that it will cut there. And the y-intercept is basically minus 7 over 3, which is 2,33. So this is basically 2,3. Minus 2,3 is not very far from here, so I can just put it here. Ish. This one likes to cause problems if you're not careful. So what we want is to write it down that this is minus 7 over 3, and then that one is 7 over 2. Okay, so please label these things, because if there are no labels, it's going to hurt. Okay, let's do the graph. So we know that the shape is that one, so we can do stuff like this. Okay, don't worry about the fact that it's small. It's just difficult to do the shape properly. Okay, does it look right? Doesn't really matter, does it? Okay, so we've got our intercepts right there. We've got our shape. So you get a mark, okay? Of course, you label this one that this is F. Yo, my F looks crazy. So that is F. So label it somewhere. Now, what do we want? We wanted to show the intercepts, so any one of the intercepts is correct. And then we wanted to show the asymptotes. Any one is correct. And then we wanted to show the shape. So the shape, the other mark is for the shape. So that's how you get those 3 marks. And then we move on. So the question says determine the equation of the axis of symmetry that has a positive gradient. Now, a determination can be by calculation or by inspection. But this one, we can't without a calculation, right? So we may have to do a calculation here. So to answer 3.4, we know our f of x is 1 over x minus 3 minus 2. So we can say now this implies that the axis of symmetry with a positive gradient is such that y, maybe let's just not even say what we are saying here, is such that y is equal to x minus 3 minus 2, which therefore concludes that our y is going to be x minus 5. That's it. So that's what we do. It's very easy. So if you don't know where this is coming from, there's a video I just posted not so long ago on grade 11 functions. There are notes I left for you there, so I'm not going to explain. And for the sake of saving time, I'm not even going to try and say more than just that. So basically here we know that this is how you score those 2 marks. Okay, great. So 3.5 says the graph of f is transformed to obtain the graph of h of x. Now look at that graph of h of x. We no longer have those asymptotes, so they were eliminated. So now it says describe that transformation. Obviously, for us to get to this transformation, it means in f of x, we had a situation like this: x into x minus 3 plus 3, then minus 2 plus 2. So what we did here, we added a 2 and a 3. So now if we add a 2 on the y values, that's a vertical shift up. So that's a vertical shift upward. And then if we add a 3, that's a horizontal shift to the left. Okay, by those values in terms of units. So we can say h of x equals 1 over x is the graph of f of x shifted 3 units to the left and 2 units up or upwards. Great, that's it. So you've described the transformation, the 3 units to the left horizontally. Perhaps we should say that the 3 units to the left horizontally and 2 units upward vertically. But I mean up and left, I think it makes sense. Let's just not say too much. Otherwise we're going to start becoming ridiculous. Okay, let's do 3.6 and end this pain of this question. It says now write down the domain of h. Now the domain of h, it means simply this graph is basically this standard graph here. That would be the graph of h essentially. Now what do we see here on this graph? We can see that, okay, the x values come from negative infinity, but because this line x is equal to 0 is an asymptote, it is not included. So we've got this situation here. The x values can go to infinity and negative infinity, but they can't take a 0. Okay, so that's it. That's just the domain there. So we can just say the domain is equal to a set of x values such that x is an element of real numbers, but x cannot be equal to 0. Or you can say x is not equal to 0. Because if x is a 0, then we will get an asymptote. Remember, we can't divide by 0. It is undefined. So that is why it is like that. So a very nice 1 mark there. So we take our 12 marks with a very big smile indeed. And we are certainly feeling hopeful for the future. So let's quickly chase question 4 down. Let's chase that question 4 down. So we're given f of x is equal to minus x squared plus 6x plus 7. So this is a standard parabola. But now on this standard parabola, we can see that our a is greater than 0. A is a coefficient of x squared. And if that is the case, we expect our parabola to look stuff like this. Now, we need to be very smart about our business here. What do we know? If this is positive and that is negative, already tells us that our axis of symmetry is going to lie to the right. Okay, so we know that our graph is going to look stuff like this. Okay, so our x-coordinate of that turning point is to the right. And then, of course, the y-intercept is there at 7, which is positive. So this is the graph that we expect, a grumpy face, because of that a value there that is less than 0. Actually, I made a mistake here. I can't write like this. I cannot write like that. That should be less than 0. Okay, easy. Now that we've explored a few things, let's just keep working. It says now determine the coordinates of the turning point. Now determination, we know that it is by inspection and or calculation. Obviously, we're going to stick to this one for this because we didn't get a graph and there's no way of just knowing that without calculating. So we cannot do inspection here, unfortunately. Or fortunately. So 4.1, we know that we are given f of x is minus x squared plus 6x plus 7. Okay, I can actually work this one out and factor out this guy and say this is going to be x squared minus 6x. And then now we know that we can add half of the coefficient of x. I'm just completing the square now. Half of that is a 3, and then we square that. And then this becomes a minus 7. And then we immediately subtract the same thing. Because if we added it here, we must subtract it here so that it can disappear. Okay, so now let's see. We work things out. We take what is under the square. We take the original sign. We take what is under the square. And then we square that thing. So this is going to be minus 7 minus 9. Okay, we sort this out. We FOIL this business out. It's going to be minus into x minus 3 all squared. This is minus 7 minus 9, which is minus 16. And then times minus 1 is going to be plus 16. Okay, so I'm doing this. And then I can say safely, therefore, my turning point is going to be, we take the opposite of that constant term inside the bracket is going to be 3:16. We take that one as it is. So I basically converted my parabola or quadratic into the vertex form or the turning point form. so that I could determine easily my coordinates of the turning point. Okay, but you can use your other formulas. You can use these formulas. You can use x is equal to minus b over 2a, and then y is equal to 4ac minus b squared over 4a. Or you can say y here is going to be f at minus b over 2a to solve for y. Either way, you will get the marks. Okay, so these are your options in determining the turning point from that equation. How many marks are we getting here? We're getting 3 marks. So basically my vertex form is a mark, and then each coordinate is a mark. So that is how easily those 3 marks could be arrived at. So let's do 4.2 quickly. It says now write down the equation of the axis of symmetry of f. That's easy because we just take what is under that square and we equate it to 0. So we know that we solve for x. X is going to be 3. Or x is literally the x coordinate of the turning point. That gives us the axis of symmetry. So let's do 4.3 easily and quickly. Now it says the graph of f is shifted 4 units to the left, okay, and is reflected in the x-axis to form the graph of h. Okay, now it says write down the equation of h in the form, they want the turning point form. Thankfully we have done that for our graph of h. So do you see some techniques actually work? But what I can advise is that don't answer question for question. When you get to a question, interpret your question as best as you can, and then skim through all the questions that are asked, because the way that certain questions come about, they already determine how you could safely prepare above for those questions. Okay, do skim and scan all the questions before you answer the individual questions. Anyway, so now we know that find h of x is basically equal to minus, because a reflection about the x-axis, we multiply the entire function of f by a negative. It's going to be minus into f of x. Now the x, if we're shifting it to the left by 4 units, we're going to say plus 4. So that is those 2 issues that we are provided here. We are first reflecting it about the x-axis. That is the vertical reflection, or a somersault, or a flip-flop. And then translating it to the left by 4 units is this business right here. Okay, so we are good. So let's just continue doing our business here. So this is going to be minus into f of x, already in the vertex form, is basically minus into x. Now we're going to say plus 4 and then minus 3. That was there initially, all squared, plus 16. So that is the story. So you see, just complex things and you make it work. Now here we can do our final gymnastics. This is going to be a positive. x4 minus 3 is just plus 1 squared. And then this one times our 16 is going to make it a minus 16. So that is what we are doing. We reflected it and shifted it about. Easy determination, okay? So we're getting 2 marks here. The first mark is knowing that we have to multiply by the negative. And then the second mark is to know that we're plusing that 2. Okay, maybe we can just say half a mark for these ones. And then the last mark, because the final answer is important, we need to do that. Okay, all right, okay. Let's quickly do question 5. So we are smiling a little bit more with just the 6 marks here. That was just a bit of, you know. question 5 says 5.1, we are given g of x is equal to a half all raised to the exponent x minus 4. Okay, so now we need to inspect our function. Nice and easy. Now what do we know? Maybe let's just do it here. Or it's fine, we can do it there. I mean, we need to do our business just right. Of course, guys, you're not gonna do this in the exam. You will just know this is what is going on. So let's look at this base. Okay, let's first look in front of the base. What is happening there? There's an invisible one. Okay, that becomes the coefficient of that power. Okay, the coefficient of that power is simply the story that says a. So this a, always remember, is the coefficient in this function. So we know that our a is greater than 0. In this case, it's just equal to 1. Okay. The other issue that we need to entertain is this base of our power. The base of our power. The power being the base together with the exponent, okay? Not just the exponent, okay? Now we can see that here we have a situation. We've got a situation there that this base, we can see the base we normally use b. It is less than 1 but greater than 0. Always the base has to be greater than 0, otherwise that does not exist. Okay, so that base is between 1 and 0. Okay, now this combination simply says we are going to have a function of g looking stuff like this. Basically an a value greater than 0. It says our function will have a graph that appears above our horizontal asymptote. But now what is that horizontal asymptote? It is the constant term or the vertical shift. So that makes up for the vertical shift, which is essentially the horizontal asymptote. So there's only one asymptote here. So we expect our graph to have our horizontal asymptote at minus 4. So it's on the negative sort of. So that is our business. So that business of ours is, so it's minus 4. Okay, great. So that is our x-axis, and that is our y-axis, and that is the origin. Okay, great stuff. Now, what do we see? We want to draw the graph. So what will this graph look like? Let's see. If we work out the x-intercept, it's going to be positive, right? Right. Is it going to be positive? No, it's going to be negative. So our x-intercept is going to be somewhere there. And then our y-intercept is obviously going to be negative as well. It's going to be a negative value. When x is 0, what would be y? Okay, it's going to be 1 minus 4, which is minus 3. So it's going to be somewhere there. So this graph is a decreasing function. Okay. So our graph of g is a decreasing function because when the base is less than 1 and greater than 0, with a greater than 0, it is a decreasing function. That appears above the horizontal asymptote, which is that constant term there. Okay. So this is what you need, guys, to get into the habit of doing. You see, a sketch graph that is almost accurate of what you are being given is going to save you from yourself committing suicide. I think we've done enough interpretation now. So let's work. So 5.1.1 says write down. So equation that says write down, it means an answer only is good. Write down the equation of the asymptote of g. It is always that constant term or the vertical shift. So y is equal to -4. 1 mark, so 5.1.2 says again write down the range of g. So range is y values. So what is this g? If you're looking at g in terms of the vertical axis, we see it all the way. Okay, maybe let's use another color here. We can see that except for this, because it is undefined at -4, but we see it anywhere above that line. So that means y values must be greater than -4. So we can say here the range is equal to a set of y values such that y is greater than -4. That's it. Because it can't be equal to 4. Why? Because that is an asymptote. The graph is undefined. Easy 1 mark. Again. So 5.1.3. It says now determine the coordinates of the x-intercept of g. Obviously, this one will have to do by calculation. We can't do inspection. So what do we know? We know that for the x-intercept, it is such that 0 is equal to 1 over 2 to the exponent x minus 4, right? Right. Now this says we can transpose the -4 to the other side. It becomes positive, equals a half to the exponent x. Now we can see that, okay, there's a relationship between these two. We can easily say this is 2 squared equals 2 to the exponent minus x, right? We convert this to a negative exponent. All we want is for these bases to be the same. Then we can simply equate the exponents. Now when we equate the exponents, this implies that 2 is equal to minus x. Therefore x is a -2. Great stuff. And therefore our x-intercept, because we're asked coordinates, it's going to be -2 is to 0. Okay, now that is it. That's the answer. So let us mark the thing. So we're getting 3 marks. Of course, knowing that we're substituting with a 0 there is important. Very important. Perhaps, I don't know, man, because this is not algebra anymore. We're applying algebra instead. So we can simply say the correct substitution there and the final answer. That x is equal to -2 is a means to an end. Okay, so we're not really testing algebraic techniques. We are applying them. So now let's do 5.1.4. It says hence, that means we have to use what we just did. Write down the values of x for which g of x is less than 0. Now you can already see, if you drew a sketch, the thing is, for this graph to be less than 0, it has to be running along here. You can see that it is 0 here, and we don't want 0. It's not included. Let's look for another color. Is there a color? Maybe let's use this one. So we can see that this point here at -2 is not included because we saw that that is -2. So that is a -2. So we don't want the -2. But we can see that as we move from that -2 to the right, all the way to infinity, this graph is negative. So it's running on the negative x-axis. So that is essentially what we want. Do you see the hence part? It's because we already found the intercept above. So we can just simply say x must be greater than -2. Okay? You get your mark and you smile like you are about to die tomorrow. So you're trying to have as much fun as possible. Okay, let me show you another technique. Say sometimes you didn't realize that this is going to work. I mean, you can just solve that thing algebraically. So you can just say g of x is less than 0. This implies that a half to the exponent x minus 4 is less than 0. You just have a half to the exponent x is less than 4. Okay, just simply do the same thing. This is 2 to the minus x is less than okay, that is not quite correct, should not write like that. So this is 2 to the minus x is less than 2 squared. All we wanted is to do this. I mean, you can do an algebraic solution. So you can have here this implies this still implies now that minus x is less than 2. And then now we multiply by minus 1. This tells us that x must be greater than minus 2. So you can do an algebraic calculation to do this work. It's still okay. All right, okay. There are some little options I would like to show you even, so that you can be the master of your own fate when it comes to maths. I don't want maths to be an issue. Now let's say we want to take this and say, fine, this is a half to the exponent x minus 4 is less than 0. Now what do we do here? We simply take this expression, we put it on the table, but now it's all alone. So what we're going to do here, we're just going to work out on the number line. Okay, on the number line, we can only solve for x. When we solve for x here, we get a minus 2, right? Right, we saw that. And then we say now, fine, let's put a minus 2 there. When there's a minus 2 there, what do we get? Say 0.5 to the exponent minus 2. It is a 4. 4 minus 4 is a 0. Okay, so we're going to get a 0 here. So be confrontational, okay? I don't know why this thing likes hearts. I'm not the romantic type, simply though. I'm a true rural man. Okay, leave me alone. I don't do this romantic stuff, you know. They just irritate me, actually. Anyway, anyhow, let's have a look. Now, when you put a number greater than that, say, for example, you put a 0 out of convenience. This becomes 1. Now, anything to the exponent 0 is a 1. So that means we will get a negative answer here. Okay? I can tell you that. Even if you put a 2, for example, 0.5 to the exponent, say a 2, you get a quarter minus 4. It's always going to be negative, okay? And then if one side is negative, this side should be positive. So what did we want? We want this graph to be less than 0. So where are our solutions? At 0, we've got a solution that is not included because it's not saying equal to 0. But we're saying it must be less than 0. It's less than 0 going in this direction. Hence, we make the same conclusion. Okay. So guys, we've got options. Please make sure maths is no trouble at all. You learn and learn and learn and learn and never stop. Okay. Let's keep going. 5.2. Oh, no. 5.2 says point A, which is 3:54, lies on the graph of f of x equals 3 to the exponent x plus p minus 27. Okay, so basically this is a horizontal shift, while this one becomes a vertical shift. Or a horizontal asymptote of our function. Okay, not a problem. So let's see. What do we know? Again, we need to do our gymnastics here. Don't be in a hurry to finish. So if you look there, you will see that there's an invisible one. There's always a coefficient of that power. Remember that power cannot be negative, but the coefficient can be. All right? So what do we say now when that is the story? The issue is that when that is the story, we can easily see that, well, our a is greater than 0. And what do we see? We also see that, oh my Lord, look at the base. The base is basically a number greater than 0. Greater than 1. So when you have a base of greater than 1 and a of greater than 1, this combination says we have an increasing function that appears above the horizontal asymptote. Okay. So these are the x's. Now let's do the graph. What is this graph looking like? Now we are saying the horizontal asymptote is at -27. So if we can say that is the story right there. So, okay, please take a bit of a moment, guys. Don't always try to be in a speed. You know, most you're told speed kills, so try not to die. Assemblief toch. Now let's see, where will this x-intercept be? Obviously, we don't know the value of p, so we can't really say. But at this point, of note is that the y-intercept is going to be a -1, okay? Without a doubt. And the x-intercept may actually be positive. So, to draw our graph, it's going to be something like this. So, you see the shape, you can already figure out from what we saw. So, this is f, okay? Great. So, that is the story. So, already knowing these two things could already tell you where you're going. It says where we are going is home bafowethu. Abagalabe re a hae eseng kai mafateng re a hae jwale. So we've done our work, guys. It looks nice. So when you have these sketches in your mind, you can answer any question. You can even draw them if you want. But now let's answer the questions. 5.2.1. It says determine the value of p. So obviously we know that f of x is equal to 3 to the exponent x plus p minus 27 through point A, which is given as 3 is to 54. It is such that 54 is equal to 3 to exponent 3 plus p minus 27. Now we transpose that constant term to the other side. 54 plus 27 is 81, which is equal to, now 3 to the exponent 3 plus p. Now can we express this? Our key now is this base. Can we express 81 in terms of a power of base 3? Yes, we can. It's base 3 to exponent 4. This is 3 to the 3 plus p. Now once our bases are the same, we simply equate the exponents. This implies that 4 is equal to 3 plus p. Therefore, p is going to be 4 minus 3, which is 1. Okay. Now, we were asked to solve for p, so we've solved p. No issues there. Now, how many marks are we scoring there? 3 marks. Obviously, substituting these things in the right place is important, and also that substitution should be important because the rest is algebraic techniques that we are applying, right? Right. So the answer. So essentially the rest is your own indaba. Kitaba tsa hao ntate tseno e seng tsa rona kaofela. Let's do it. Determine the range. Of course, now we can determine the range by inspection or by calculation. Okay, so which one do you choose? I think inspection is better because we've been given an equation. Always knowing the shape of the graph, this becomes our friend to look at. This minus 27 already tells us the lowest point that this graph should be attempting to reach but will never reach. So by inspecting that equation, we can see here that the range is equal to a set of y values such that y is greater than minus 27. You don't even have to think about it. Or if you did a sketch, you will see that this 27 is an asymptote, so the graph is undefined, but we see it everywhere else above that. So you can use a sketch that you drew on your side. Or you can actually include the sketch if you like. But since we have an equation, don't even have to bother with the sketch. But if we did not have an equation, perhaps would want to think about it. Anyway, that is an answer right there. So 5.2.3. Okay, let's finish up this question before it chows too much time. Now it says the graph of G is obtained by reflecting. Now a reflection, it's a flip, it's a flop. So we reflect about the x-axis, which is what we call a vertical reflection. We can reflect this graph about the y-axis, which is what we call the horizontal reflection. We can actually reflect a graph about a line y equals x, which is what we call an inverse. Okay. All right. Okay. So what happens with a reflection that is vertical? You simply multiply the entire function by a negative. Okay, that's a vertical reflection. Now what about a horizontal reflection? You simply multiply all the x values by minus 1. Okay, and then what about the reflection about the line y equals x? You simply switch x for y. Nice and easy, né? Great. Now we're told here this is reflected about the x-axis, so this is a vertical reflection, meaning going to multiply the entire function of f by a minus 1. Then we are going to obtain the graph of G. Now it says determine the coordinates of the y-intercept of G. Okay. Now that means we've got two options. We can find the y-intercept here at this point right now, here, and now we can find out what this is. Okay, and if we find that out, we know that we're going to simply multiply all the y values by negative, so we'll just shift it to the other part. Or we first reflect this thing and then we solve. So whatever you want is up to you. So let's deal with this graph of G. We know that G of x is basically f. Now this is minus f of x, right? Because that is a reflection about the x-axis. Now let's sort it out. So this is going to be minus into 3 to exponent x. We found p to be 1, minus 27. Okay, that is it. And remember, this is just minus 1 multiplied by that. That base is not negative. So that negative is not for the base, but it's for the coefficient of that base, okay, or of that power as a whole. I remember that. Now we can say, now the y-intercept is such that we have y is equal to minus into 3 to the exponent 0 plus 1. Remember, this is like this, guys. Be careful not to mix things here. You're gonna get hurt. So now 3 to the 1 is 3. Then we multiply by that. So it's 3 minus 27. So this is minus 30. So that is not true, is it? I doesn't agree. Oh, I did not multiply things properly. Remember, this negative bafowethu multiplies everything. Ne? So when we do that, here it becomes positive. Okay, in fact, we did not finish our determination. That's why. So always, when you're doing these kinds of questions, understand if the question makes sense. Do you know why I know this is wrong? It's because my sketch says I cannot be below minus 27. So that's why I know this is wrong now, to get a minus 30. So it means my simplification was not on point. So this is minus into 3x plus 1 plus 27. So this one switches positions. Right. Now we can say for y-intercept, it is such that y is equal to minus 3 to the 0 plus 1 plus 27. Now this says to us, this is 27 minus 3, which is 24. Okay. All right. Okay, we can say now, they said coordinates of the y-intercept. So we can say now, therefore, the y-intercept is going to be such that 0 is 224. Now that makes sense, because we know that, of course, when we flip this graph, it's going to flip in this manner. What can I choose? Maybe let's choose a dark blue there. Maybe let's choose this one. When this graph flips, it's going to do stuff like this. This asymptote comes up there. So that asymptote goes up there, okay? And then our graph would look something like this. It becomes a decreasing function, but they will have the same x-intercept. Why is it so? It's because we know that when a, maybe let's look at the actual function. When a is less than 0, okay, that together with the base that is greater than 1, that gives us a function of x that appears below the horizontal asymptote and effectively is a decreasing function. So we know that we were looking at something like that already. Okay, these are the x's, the origin. Okay, so guys, please pay attention to a lot of knowledge. It will save you a lot of an embarrassment. So know these kind of things. I know this looks like me being overly, interpretative, if you want to use that word, if it does exist, or probably obsessed. If you're not obsessed, trust me, you're not gonna see any day of light, because things are not going to make sense. And if they don't make sense, you're going to suffer. Do you realize why the x-intercept doesn't change? Can anybody answer me? If you answer that question, why the x-intercepts do not change here, why does it cut at the same x-intercept? If you can answer me that question, I will give you $100, okay? So you are going to get, maybe let's make it a bit better, 250 rands, okay? I want a detailed answer why what you call the x-intercept is the same as for the other function when we're doing a reflection vertically. Okay, why is it so? And I want that answer in the what you call description, and I expect that answer. Of course, I'm never going to accept any answer that is going to be longer than say tomorrow. So at the end of tomorrow, 12 midnight, any answers that have been posted less than that time, I am not looking at them. But I'm not gonna give everyone who gets it right. So I'll take all the people who get it right, okay? And then I will do a bit of a raffle, okay? And I don't know how that raffle is going to be, but I will see how to do it fairly so that you can see no one got robbed. I'll probably do a video doing the raffle. At least you will see that. Just take my camera and you will see me doing the raffle. And whoever gets picked out will win the 250 rands. I hope that is correct. But don't go and buy drugs, okay? Go and buy a pencil case or something that is going to aid you in mastering maths. I'm only teaching you guys so that you become the best. I'm not teaching you here so that I become popular, okay? Great, let's go on. We've got 3 marks. First of all, I can tell you for a fact that getting that equation determined is important, because if we did not do that reflection, we would not get anywhere. And then the second mark is knowing that we have to replace x with a 0. That is the second mark. And the third mark is basically those coordinates, because they asked for the coordinates. Okay, all right, okay. So that is essentially our 13 marks, guys. We have a smile of an elephant. Does an elephant smile? I don't know, whatever. Sesithi ngesixhosa luncumo lugoso luka blanket, okay? Uncumo lugoso luka blanket. Andilazi noma lunjani, kodwa ke ndaluva nami kuthethwa ngalo. Labese ngiqonda, you know what? I'm gonna use the phrase. Now let's do the last dance, guys. I can tell you we've been cruising, so we are probably gonna get ourselves hit with some stones somewhere, somehow. So I always told you there's gonna be simultaneous equations. So you can see we're given 2 functions here. So that means at some point we're gonna have to solve simultaneously, right? That's the technique we learned in question 1. Okay, let's just work. I don't like this color, so it's too iqanda kakhulu man. Iqanda ke le hendata ke rati mahi. Oh, kyadlala, kyawabala, kyawarata. Oh, hane ke le monyane ne ke tlosa le kgoho mona e dutse hodima yona ke batla lehe fela. Haeba ha ke je mahe ne ke batla lebese. Okay, ke nna he eo ke sa le monyane. Ebile le ka sheko ke sa di rata ntho tse ho feta tse ding tse di teng mona. Ebile ke na le yona tjhelete ya ho reka ntho tse ngata tse monate. Ha ke di rate kaofela ho feta masa, ho feta lebese man, le butsuweng empa le mahe. So technically, if you did not get that one, what I'm saying is this one is too yellow, it's too kandaman, it's too eggy, it's like an egg, okay? And actually, when I grew up, when I was a small kid, I preferred to eat eggs or sour milk, okay? And I still love those things today, even better than anything there is. At home, they would slaughter a chicken or whatever. I would not want that meat. I would want an egg or sour milk. Okay, I preferred those over everything else. I don't know why. But anyway, as I grow up, I realized that actually not attaching to meat was for my own good, because all of them in my family have hypercholesterolemia. Imagine if I liked red meat, I would be dead. In fact, of all the meats, I preferred chicken. Even the chicken, I preferred the one without the skin. I preferred the muscle. Can you see? Somehow God was speaking to me that, look here, you little big-eared freak. You are going to live longer, whether you like it or not, because your folks have these kind of problems, and you are also genetically at risk, okay? So you better start building your body properly from the beginning. And I can see I'm definitely a lot younger than my actual age. And you know why? He's big horse. Anyway, folks, I'm just talking nonsense, but there is some truth to that nonsense though. Okay, I was just trying to breathe. Okay, in the last 20 minutes, let's try to answer this in 20 minutes. And then we can finish. Of course, we're going to be 20 minutes beyond the time. You would be told it's time up. But I kind of wanted to chill a bit. You know, you don't want to chase this too much. Yeah, but this is also too long. Let's run. Okay, in the diagram shows the graphs of f of x. Okay, f of x is that one. Now, I don't need to entertain you with a lot of things. You can see here the coefficient of x is negative. So that means our parabola is a grumpy face. 2, this is positive. The middle term is positive. That actually helps us to calculate the coordinates of the turning point. So now let's see. This becomes negative, divide by negative, it becomes positive. So it means our turning point is inclined to the right of the origin. And is it not so? There is the axis of symmetry. So that is true. So the y-intercept is the constant term plus 15. Can you see the y-intercept is positive right there? So essentially what we see here is definitely that graph. Okay, that's a quick method now. Let's look at this one. Straight line graph, the gradient is a negative. So when the gradient is a negative, it is a decreasing function. And we can see that as we move from left to right, that graph is taking a dip. Okay, that's it. And then we can see that the k value there is essentially the same y-intercept as that for the parabola. So this simply says k is equal to 15. Of course, we'll have to justify ourselves on that one. Already now we know that we have enough information to run the race. So what can we do? They're telling us that the graph of f cuts the x-axis at a is given by -3 is to 0 and b given by 5 is to 0. So we are given those x-intercepts, so we are fine. And the y-axis at c and has a turning point at d. So d is the turning point. Okay, we can determine the coordinates of the turning point. We don't have to worry. How can we do it? We know that the average of those 2 points, which is the x-intercepts, is going to give us the x-coordinate of the turning point. So 5 minus 3 is a 2. 2 divided by 2 is a 1. So we know that the x-coordinate at the turning point is 1. Then we take 1 into our equation there. We can actually work out what the turning point is. Okay, that is going to be 1. So now let's just do it. Do we really have to? I don't know. But maybe let's do it. Minus into 1 squared plus 2 into 1 plus 15. That gives us a 16. So this is 1 is to 16. Okay, that's just us working out things ahead of the questions, because we don't want to be struggling trying to figure out what we can do. So when you have a graph, you can use the graph to the very best of your ability. Let's read further. It says now the graph of G cuts the x-axis at B. Again, we can see that's a point of intersection of the two. So it's a common x-intercept. And y-axis at C, again, it's a common y-intercept. So that's fine. We can see it. Is the point on G such that DE is parallel to the x-axis. So what is the significance of that? The significance of that statement is that DE being parallel to the y-axis, it simply says the x-coordinate at E is 1, as you can see. Then we may have to find the y-coordinate. Okay, that is something we can consider for later. Okay, now that we have all things in order, let's start answering. 6.1 says show. Now once they say show, as much as we know we could easily just do it, but now we're being forced to show. Now that means we can't just show up with an answer. Even though this is just 1 mark, we have to show. So no shortcuts. So what can we say? We know that K is the y-intercept of G of x, which maybe we can say which has a common y-intercept with f. of x. Trust me, these statements may look crazy and a waste of time. You need to converse with the person who's marking your paper. Trust me, when you make their job easy by words, you actually get all the marks. Even when you get it wrong sometimes, just because you are so direct and you clearly show that you are confident about your work, you are able to explain it to somebody, and you're making their job easy in marking your paper instead of trying to figure out what are you actually doing now, because you may find that the memo is not saying the same thing. Now, when you explain how you're going about it, they actually start to click into your conversation. And in a way, they may just be like, if you mess up a sign somewhere, they'll be like, come on, man, this student is hot. So don't think those people who get 100%, they actually scored definite 100%. Now, there were mistakes along the way, but because they were very elaborate about their work and they're very clean, they are very, they show that they understand maths. This is why you don't even find any means to really take them down. Obviously, someone who's grumpy may do it, but those ones, they make you not even want to do that. Okay, so please guys, to get 100% is not really scoring 100%, okay? But it's essentially doing the right thing, enough for someone to overlook some of your flaws along the way, because pressure is understood. But anyway, I'm not saying those who got 100% didn't actually get physical 100%, but I would love to see their scripts, because I know mistakes do occur when you are confident. The only way you can escape them is if you maintain vigilance. You finish, ahead of time, and you have time to check all your answers, and then perhaps you could. But usually that is almost not going to exist, because those papers are very long. So mistakes, man, are a natural thing. But I'm telling you, when you become clear about what you're doing, you're almost likely going to get full marks, even if you did not technically get them. Anyway, anyhow, don't even whisper what I said to anybody who's your teacher, because they will start changing, their kindness. So don't say it. This is a whisper into your ear. It's between you and me. Please don't say it. It's a secret thingy. It's classified information. Anyway, guys, now this implies what? This implies that K is equal to f of 0. Because f of 0 is the y-intercept of our parabola. That statement actually ngumandlalo esolala phezu kwawo ngoku sesilala emandlalweni ke ngumandlalo wethu utsho njalo. This is minus into 0 squared plus 2x. Wena suphaphu x ungenaphi ngo 2 into 0 plus 15. So this is basically 15. So we have shown, even though this thing was 1 mark, trust me, you're not going to get a mark for that, because you are already told that value. So you're not going to get a mark for that value. The mark is saying that story, Baba. And that substitution, Baba, that is what matters. The rest, is a different story. So this is the story, okay? But that story is explained by the statement above. So that statement is like, a start. And then this one is the main cause. Let's move on. 6.2. Let's not lose time now. Determine the coordinates of D, the turning point. Okay, guys, this is easy. Now we know that we can do this by inspection and or calculation. Right? So I would opt for this one, because the inspection is not going to be very great here. We don't have the turning point form, so we can't say we're going to inspect, but we will have to manipulate that. At the same time, we have a graph, so we can just use the graph. We know that the x at D is going to be the average between those 2 points. It's going to be minus 3 plus 5 over 2. Okay, that would be the axis of symmetry. So this is now 2 divided by 2, which is 1. We can say now y at D is equal to f at 1. bafethu, imaths imnandi. Imaths imnandi. Ndiyanixelela. And we already worked it out. That is going to be 16. Wantushisa. Wanitwa kahle. So we can say therefore D is this point 1:16. We sorted it by calculation, but using the resource that we were given, the graph. Not a big deal. So we're getting how many marks there? 3 marks. Okay. This business is correct. And that business is correct. And essentially, that business is correct. Putting it together is the final answer. That does not really get a mark, okay? Or somebody can decide to give you 2 marks there. But I think it's much better when we distribute it in those calculations. Not a problem. So let's look at 6.3. Okay, 6.3 says determine the values. Again, we're saying a determination can be by inspection or calculation. Please keep that in mind. And you can see this is 1 mark. So you wouldn't want to do a calculation for just 1 mark. Let's just look at inspection. So this is easy because we have a graph. So when we're saying the values of x for which the graph is increasing, when is the function of f increasing? When it takes positive gradients. So if we draw a tangent line here. So do you see that tangent line touches the graph there? Now, that tangent line has a positive gradient. Okay? The gradient is positive. Therefore, the graph is increasing because we can see as we move from left to right, that graph is climbing. It's increasing. But at the turning point, when you draw a tangent, what happens? The gradient is 0 because that is horizontal. So we don't want that. If we draw another tangent on this part, what happens to this tangent? We know that this one has a negative gradient. And therefore, as we move from this point D, and we're moving across, the graph is decreasing. So essentially, by inspection, this is our interval. Infinity, in fact, this one goes to infinity. Maybe it's even better to show it this way. That we know that this x-coordinate here is not included because that graph is at 0 gradient in that position. But as we move to the left, we can see that our graph is actually increasing. In fact, we're moving from the left to this side. But yeah, whatever, man, you get the point. So here we can see that x must be an element. I mean, we can simply say when x is less than 1, we can see that our graph is increasing. Let's not even bother ourselves with a lot of stories here. They don't matter. Or some people can write x is an element of negative infinity, which is never included, and 1, which we cannot include because that is the story. Or others may write x must be less than 1, greater than negative infinity. So these are just your options in writing that same answer. So you choose whichever makes you smile is fine. So let's look at 6.4. It says now calculate. Here you can't be showing up with an answer. The average gradient between points A and D. Okay, so let's just remove these ones because they were means to an end before they start causing us a few issues. They were a means to an end, so when we are done working with them, we don't need them anymore. All right, so 6.4 says calculate average gradient between points A and D, and we can simply see that, okay, between A and D, oops, no, not that one, D is here. That would make us a positive gradient, right? Yeah. Sometimes you need to be a little bit accurate. Shit. Anyway, guys, this is starting to irritate me now. Damn it, man. Damn it, man. There you go. Now we can see that that is a positive gradient. So we expect that much. So we can say MAD is going to be equal to y at D minus y at A divided by x at D minus x at A. Y at D is 16. Okay, minus y at A is 0. Divide by x at D is 1 minus x at A, which is minus 3. This is basically 16 divided by 4. That is a 4. So we did expect a positive gradient. And it's fairly steep, so it's good. So here, correct substitution and answer is your friend. Okay, let's do 6.5. Now 6.5 says calculate the length of DE. Now DE, okay, this one was a means to an end, must go. This friend must go because it's going to cause us problems. Now we want to work out DE. But now we saw that that is a vertical line. And this line lies on the graph of G. So essentially we need to find the coordinates of E. Already that is 1. So if we substitute 1 in there, that is basically 15. So minus 3 plus 15 is basically 12. So we needed the y coordinate at E, because since this is a vertical line, the y at D minus the y at E gives us that line DE. You know. So what we can say here, fine, we know that the y coordinate at E, okay, maybe let's start there and say no, that is not the story. We know that the x coordinate at E is equal to the x coordinate at D. That is a vertical line, or we can just say DE is parallel to the y-axis. That's what we're told. Please don't refrain from using Euclidean geometry techniques, because you will regret not doing these in grade 12. Trust me, those people are stressed. There's lots of people writing those exams. There's lots of people having to mark, and they need to have just those few weeks to finish the marking. If you're making the marking process very difficult and challenging, you are going to suffer the consequences. So when you are very clear and elaborate, nobody will make a mistake, even if the memorandum didn't approach it the way you did, which can negatively affect you if someone who's marking is also not clued up in the subject, which is possible. There's a lot of people who do maths and teach it, but they don't really quite get it properly. And sometimes it's just an error of judgment, which everyone has. So it has nothing to do whether you know or you don't know, but maybe at that moment your brain is just somewhere else. Now you want something that is straightforward, and then you get someone who's going sideways like a snake. You're like, what the hell? Penalize without noticing that actually you are causing a problem. Of course, the process is made safer in that there's some people who moderate these things, but I can tell you, if I'm an examiner who is trusted, anyone who moderates that paper is more likely to fall into my mistakes because they think I know better. So be careful of such things. That's why I always make it a point that I show you the techniques to ensure that you capture the attention of someone who's marking you, enough for them to even slip away from that memorandum, but to follow you, because then that means you are talking the language. Now this means that is 1. Easy now. Now we can say this implies that y at E is equal to minus 3 into 1 plus 15. Right, because we can see that E lies on G. Yeah, maybe let's just write lies on G. So you see, please guys, don't take these things lightly. I'm telling you, this is now 12. Can you see? Yes, we did it there, but we have to show how we did that, because the question said calculate. So we can't just show up with an answer that doesn't make sense where we got it from. Now we can say then DE is going to be y at D minus y at E. Again, this is because this is a vertical line. A vertical line, when you want the distance, you just simply take the difference of the y values. So this is 16 minus 12, which is 4 units. Easy stuff. Nah. Yeah, man. This thing is proper. Okay, now we're losing time. Let's finish up. 6.5. Now 6.5 says if h of x is given by f of x minus 1 minus 2. What are we doing? This is a right shift. It's a right horizontal shift of our graph of f. Okay, so we're shifting it to the right by 1 unit. Okay, and then at the same time we are shifting it vertically down by 2 units. Okay, that says determine the equation in the form. Now they want it in the vertex form. Okay, is there anywhere where we did the vertex form of our graph of f? The answer is no, but in any case we can do it. It's not a big deal. I wish we did use that when we determined the turning point, because that could have saved us. Do you see, not skimming and scanning is a sabotage. Okay, let's see. We're going to say here h of x is equal to f of x minus 1 minus 2, which means now in that graph of f of x, we're going to say this is basically minus into a, I don't like what is happening here. This is going to hurt a lot. Let's not do this one. Let's start here. I think it's fair to start doing this. Let's write our f of x in the vertex form, because that will make our lives a lot easier. F of x is equal to minus x squared plus 2x plus 15, which is equal to minus into x squared minus 2x minus 15, okay, which is minus into, maybe I should have just done this once and for all, guys, because you know what, wasting time is not fun. So we simply add, the half of that is just 1, then we square that, put the minus 15 and immediately subtract the same thing. And then we take what is under the square, take the original sign, take what is under the square, we square that business, it's minus 15 minus 1. All right, okay, so this is now minus into x minus 1 squared. Now this is basically going to be 16 right here. So minus 16 times minus 1 is going to be plus 16. So we are great, because this gives us the coordinates of the turning point. We can say now, since h of x is equal to f of x minus 1 minus 2, this is equal to, now minus into, instead of x we put x minus 1 minus 1 all squared plus 16 minus 2, the vertical shift. Okay, so this is minus into x minus 2 squared, now plus 14. So that is our h of x. Okay guys, that is good. We're doing great, but now we lost a lot of time, and you know what, there's so much to do here. First of all, to get our equation in the vertex form is important. Two, to do the shenanigans, both of them, this shenanigan there and that shenanigan, is important, and the final answer. So that's how we score those 3 marks. Nice and easy. So let's do 6.7 quickly. Now it says for which values of x. So always this question is there, and I can tell you this was a higher grade question back in the days. So it's a higher order question, so don't take it lightly. Not everyone can answer these questions. Of course, now that you know how to do them, you can actually do. So when is f of x greater than or equal to 0? So we look in the graph. This graph of f is equal to 0 here. And it's equal to 0 there. But now it's greater than 0 in between, because when you connect these with the bar, what happens? We see the graph is above the y-axis. So this one is straightforward. X is less than or equal to 5, greater than or equal to minus 3. Nice and easy. So we're getting a 1 mark there, because they already gave us those intercepts. We never had to find them ourselves. We just needed to look in the graph and solve it. So this was a means to an end. So we're just going to take it out so that it doesn't clutter our graph. Even this one was more of a means to an end, and that one too. So we don't want to clutter the graph enough to not see what we want to do next. Okay. So that's easy. Now 6 is on. I did a crime here. So this is now 6.7.1, okay? 6.7.2. It says now, when is the graph of f of x less than the graph of g? Meaning, the graph of f must be below the graph of g. So where do we see that? First of all, if you focus on this segment right here, let's use this color so that we can see. If we see that this graph of f and the graph of g to the left of the origin, what do we see? So if you look there, what do we see? We can see that the graph of g is definitely above, because they are equal at this point. It's definitely above the graph of f. As you can see, the graph of f is negative, while the graph of g is positive. So that interval is important. So we know there that the x is 0. So first of all, we can write here x must be less than 0. Because when x is less than 0, the graph of g is above the graph of f. Okay, so the solution is basically in this manner. You say 0 is not included because they are equal there. But as we go in that direction, then we have an answer, okay? The next little piece of situation is here, okay? In this lovely interval. So if you look in that lovely interval, look at the graph of g. It's above the graph of f. See that? Yeah. And how do we write that solution? Again, they are equal here, so it's an open circle. It's not included, and we move in that direction. The graph of g is always above. So we can say, or x must be greater than 5. Nice and easy. Yeah, maniac. Yeah, maniac. That's what you can do here. So how many marks were we scoring here? 2 marks. So 1 mark for this and 1 mark for that. Technically, you can solve algebraically here. But that is going to hurt, okay? I can tell you it will hurt, because now you're going to give yourself a long route for just 2 marks. But it can be done, okay? It can be done. But maybe for the sake of not wasting time, let's not do that. Just keep that in mind. And then 6.8 says determine the maximum value of p of x is equal to 3 to the exponent f of x minus 12. Wow, they're very creative, these people. So p of x is going to be, no, base 3 raised to the exponent of f of x minus 12, okay? Let's first deal with the p of x. This is 3 to that exponent f of x. Now, what we want for our f of x, we simply want that vertex form we just did. It will save our lives now. So this is basically to the exponent minus into x minus 1 squared plus 16. And then we're subtracting 12 in there. No, I don't like that. So let's give it a bit of space. This is equal to 3 to the exponent minus into x minus 1 all squared. Now that one, 16 minus 12, is just going to be plus 4. And remember, that 4 now becomes the new maximum value of that parabola. And if that is the maximum value, we can say here, therefore, the maximum value of p of x is going to be equal to 3 to the maximum value of our parabola, which is going to be 4. So that is 81. Easy stuff, okay? Because the maximum value is when you look at this and say the turning point gives you the maximum value, because this is a grumpy parabola, right? Right. So the maximum value will be the y value, which is 4. So that's why we're putting it there. And that was a bit of a nice question. Again, this is a higher order question. This is one for the big boys and girls. Okay. But even the small boys now and the small girls know what to do. If you watched this video, you've already been transformed into a big boy and a big girl. Okay. All right. Okay. How many marks are we scoring there? 3 marks. So what is important, essentially, is this substitution right here. That matters. And then is to recognize that that maximum value needs to come out and this answer, okay? So that is what is important here. Okay, let's do the last question now, 6.9. Now we're told here, determine the values of k, for which f of x minus k, okay, equals to 0 will have 2 distinct roots, okay, meaning unequal roots. Okay, now that's a question on the nature of the roots, but again, it's a higher grade question. This is again for the big boys and girls, but even the small girls and boys are going to be transformed into beasts who can do anything. Okay, let's see how we get these 3 marks. Now let's first inspect what is going on here. For us to get 2 distinct roots, what can we do? We can recognize for a fact and without a shadow of a doubt that k is essentially a vertical shift. But now in which direction? We really don't know. So let's look at this graph now. So if we look at our graph, let's just outline it purple so that we can have stuff to work with. At least our graph is not that cluttered. So now that we have our graph, so we can just try to make it do the things that we want it to do. Now, I don't like what happened here. Let's try again. Okay, so now, if we are doing a vertical shift, let's see, when we're shifting it upward, how when one hlol like a need. Heaven. Oh Lord, this one came out. Anyway, something strange happened here, guys, so forget it. Okay, let me try again. Some stuff did its own thing here. Okay, there's our graph. Now we want to cut it. Ay man, ish. Teno nonqhela kabi kanti. Why ungenza umancane ngoku? Qhela kabi lento. So now if we're moving it up, do you realize that we're always going to have two distinct roots? So moving up has no limits, essentially. We can move up to positive infinity on the y-axis. That doesn't hurt us. But we can still move it down. From there, we can move it down to this one. But the problem now, when we moved it down to that one, we have a problem of that. This business right here is saying we will have only one x-intercept. And yet here, when we're saying distinct roots, we mean two different x-intercepts. So this means we can move it up and down, but the down part cannot be longer than these 16 units. Okay? It cannot be more than these 16 units down. Okay? Because if we move it longer, more than these 16 units down, we're going to have a problem. So now the downward part is a negative. So what we can say is that essentially 16 is our key point. Okay? To this business. So that means we cannot move this graph to beyond, or at least we can't even reach that, because we're going to have one x-intercept. And if we move it further, we're going to have no x-intercept. Okay? So we cannot allow it to move further down, and even we cannot allow it to move it down to the x-axis. So how do you interpret that? Remember, that is a downward one. So if we're saying down, we're going to say k must essentially be subtracting from our parabola. So we can just simply say k must be a negative number, 16 of some kind. But now we don't want it to be there. We can say greater than 16. So you always make up for those signs, guys. So if you're saying greater than minus 16, it means we can essentially afford to put it anywhere above that x-axis and going further. So that is the answer, basically. Using the graph, using it as a vertical shift. So we know that our k must be greater than minus 16. The minus 16 is just for making up in that. For us to move it down, we need to have f of x minus k, basically. But then we can't move it further down more than 16 units. That's why we write what we wrote. So this is the down part. But the up part is a plus, which we can see is no problem because it is unlimited. So we just needed to know the limit, the lower limit of this unlimited scenario. And that's how you go about it. So here, I don't know how you're going to get 3 marks, guys. Because what I can say here now, if we take this as a vertical shift, to see 3 marks, you're not going to get 3 marks for an answer. Remember, what did the question say? Determine. A determination can be by inspection, but now what are we inspecting? We need to interpret what we have. So we can just say, we are saying here, f of x plus k equal to 0. To have unequal roots. Okay? Maybe let's not even say that. let's just first interpret what we have. We can say this implies that, it implies that the graph of f of x is shifted up and or down k units with what am I doing now? Such that the graph has two unequal roots. We can say therefore k must be greater than minus 16 as we worked it out. Okay, but now this was a bit of a complicated stuff, but you see the part that says up and down is important. So that statement is important, and then you can get 2 marks. You can actually award 2 marks for the answer. Yeah guys, I'm taking forever, but I feel like these questions are important to spend some time. Please, when you practice your grade 11 question papers, even grade 12 question papers, when they come to nature of the roots, you're probably doing the same thing, okay? Maybe more difficult questions than in grade 11, but at the same time, I don't see any difference between grade 11 and 12. Okay, so that is how you can get your 3 marks, guys. Or, what would you do? The other thing, you can forget about that. You can just think of this one as 2 graphs. So f of x, okay, plus k equal to 0 implies that f of x is equal to minus k. Okay, you can see that as the graph of f intersecting the graph of minus k, such that we have 2 equal roots. Now if we look at it in that manner, we may want to clean up some stories here. Now when we look at it that way, remember this is a constant. So this is basically the graph of y equals minus k. So this is the function that we're dealing with. And k is a constant. So this means the graph is a horizontal line. It can be there, it can be there, it doesn't matter, but it's a horizontal line. Now what do we see? Now we can just simply fancy ourselves and say, let's say this graph k passes through the turning point. How many intercepts do we have there between the parabola and that line? This is y equals minus k. Because k, remember, we don't know what k value is, but all we care about is that it can be anything, because this is a variable, so we can even put it up there. Now we'll have only one point of intersection, but if k passes through here, what do we have? We've got 2 distinct roots, right? And this continues all the way down. So this can continue all the way down. So we can see that actually the ones that tick the boxes is this one and that one, going further down in this direction. Okay, so now we can see, but now how do we answer this? This tells you and I that the best thing to look at now, we can see that our k must be a value less than 16, which is the maximum value of that turning point. So we can say this implies that, okay, maybe we can say now for f of x equals minus k to have 2 distinct roots, it is such that minus k, now you're going to write the minus k as it is, must be less than 16, which is the turning point, because we can't have it going above or at that turning point, but anywhere below it's acceptable. Then we just solve whatever we have algebraically. This therefore tells us when you multiply by negative k, the sign changes, becomes minus 16. I hope you're following there. So this is what you can do in your rough work, okay? Then you try to write things that make sense, because it is important to show this statement right here, okay? It is important, and then this is important, and the final answer is important. So this is how you could score those 3 marks. Or the last portion, I'm trying to arm you guys with as much power as possible. So the other thing you can think about, you can say now f of x plus k equal to 0 implies, now our f of x, we can take it the way we were given. So this is minus x squared plus 2x plus 15. So certain forms are very useful, equal to 0. Now we can see our graph is in standard form because we've got our a value there, which is the coefficient of x squared. And then we've got our b value, which is the coefficient of x. And then we've got our complex term c over there. All right. So now we can just simply say for unequal roots, because this is a question on the nature of the roots. It is such that delta must be greater than 0, because you know when delta is greater than 0, we get unequal roots, right? This implies that b squared minus 4ac must be greater than 0, which implies now this is 2 squared minus 4 into a, which is minus 1, into 15 plus k must be greater than 0. I don't know why I'm squashing things there. This is now 4 times 15, that is 60, so called. And then 4 times plus 4k, therefore it's going to be 4k greater than that. So this implies that now 4k is greater than 60 plus 4 is 64. When you transpose, it becomes minus 64. We divide by 4. You can see that k must be greater than. We divided by a positive number, so nothing changes. 16. So guys, you've got options to deal with the last beast. There's plenty of ways to look at it, as you can see, and that can make you a person of interest indeed. Otherwise, from here, we scoop our last how many marks for this question? That was a lovely 21 marks. Okay, I can tell you these ones are a bit of a situation, and they took a bit longer to sort, because I thought I was gonna just do them in 20 minutes, and it didn't happen, because that was Suplex City, boys and girls. I hope you've enjoyed the video, and you are going to learn and learn and learn. Remember, I'm giving you these as examples of how you practice, how you use the knowledge that you were taught in class, and how to process information that you are given, so that you can work out any problem whatsoever. Otherwise, guys, goodbye. I will see you next time.